How's everybody doing? In this tutorial, I'm going to be covering how to create threads, physical threads. We're really creating a hex cap screw for this example. I'm going to be using information from, there's information here about fasteners. I'm not going to specifically use these, but what I'm going to be using is the threading page. Information here about threading. We're going to use the reference tables for the hex cap screws. And then the information for the assignment is here. And what we're going to be creating is a 3/8 of an inch hex cap screw. 16 threads per inch, that's what 16 here means. UNC is Unified National or American National. C, coarse thread, is a type of thread. 3C is another designation for the finishing of the thread. And then we have a 1.5 inch long hex cap screw that we're going to be creating. So document name, here we go. We can use this, copy that document, create an Onshape document here. There we go, that part number there. Good. Okay, so we're going to be using these tables here. So we have threading here. Real quick, threading. It looks like little triangles we're cutting out of a cylinder, right? So the different types of threads we're going to be using. More specifically in this class, we'll use the American National or UN, Unified National C for coarse thread. We're also using the metric threading too. So we're going to see some values in here. P stands for pitch. You need to remember that D stands for it's the depth, or it's really the major diameter minus the minor diameter. And so if we're looking at a screw here, the major diameter, the tap right here from this point to this point, and the minor is the inside to the inside. So we're going to make these, and pitch, by the way, P for pitch, is the distance between corresponding points or adjacent thread forms measured parallel to axis. The pitch is equal to the number 1 divided by the number of threads per inch. For example, a screw thread with 12 threads per inch would have a pitch of 1/12. And R is for, as an example, 16 there, 16 threads per inch, and it's also here on the reference table. So we're going to use these reference tables to build the screw. 3/8 of an inch screw right here. We're going to be looking at this row of information. We have diameters, major, minor for the threading, the threads per inch, UNC, Unified National coarse, Unified National fine, UNF, and 3/8 of an inch, 16 there. And then we'll also use this information here for creating the hex cap screw itself, and more specifically the 3/8 of an inch row. Okay, so yeah, that's how we'll create. We'll create this. We'll do a sweep cut, helical sweep cut on our cylinder to create the thread. Let's get started here. So I'm going to have to recreate this here. We'll start with the hex cap. So a 6-sided head here. I'm going to use the top plane here. Sketch on that top plane. Okay. And we'll do an inscribe polygon here. Put in that. And you're going to see that we can change the sides by moving that mouse there. So I'm going to just set it to 6. Perfect. Okay, so dimensioning. So we're going to be more specific dimensioning this for the head, the width across flats, the F value, and the G value width across corners. So you can see that the width across flats, F value here for 3/8 of an inch. 3/8 of an inch is 9/16. We're going to use the basic dimensions and nominal dimensions. We're not worried about the tolerance, maximum, minimum values. We're going to use the basic dimensions, so 9/16 of an inch. Width across flats, F. Let's go ahead and dimension that. Width across flats from here to here. What did I say, 9/16? Perfect. 3/8, 9/16. Good. Width across flats. Good. All right, that's set there. Check that. Let's extrude, sketch 1. Okay. We'll go the other direction there because I want to go the other way. How far do we extrude? That's H. That's the height of the head there. And we're looking for 15/64. It's that basic dimension for 3/8 of an inch there. 15/64 for the height. 15/64. Depth 15 divided by 64. Excuse me. 15/64. Right? Yes. Okay. Back into here. Good. All right. Let's go back to ISO so we can see what's going on. Okay. So we're going to need to do the wrenching height now. So if we're looking at this table, we're cutting off a portion that's inscribed in that circle there. It's the wrenching height, which is J, wrenching height. So really what we're going to be doing is we're going to take the H minus J, and that's what we're going to be kind of cutting off there. We're going to create a triangle we're going to cut off, a revolve cut. So we're going to need to create a triangle that's going to go through, I'm going to draw on a plane that cuts through the width across corners. So it's going to be this plane here, which is my front plane. Okay, so we're going to sketch on this front plane here. Sketch, bring it forward, P, move the planes, bring it forward here. Okay, so what we're going to do is we're going to create kind of a triangle here, and we'll do a revolve cut. I'm going to need some lines to work with. Construction, use and project, but we're going to need this line here so I can snap to it. All right, turn that off. Let's draw our triangle that we're going to use to cut. From here to here to here to here. Good. Let's do some dimensioning. So I'm going to need to know this dimension here. So that dimension is going to be H minus J. So I know that H was, what was H? The height, 15/64 minus the wrenching height, 0.16. So we're going to do 15/64, remember order of operations here, minus 0.16, I believe, is what it was. I'll go back and double check. 0.16, yes, good. There we get that value. Okay, what's next? Okay, so we're going to have to kind of get that angle. We know the angle is 30 degrees. Tolerance is plus or minus 15 degrees, but we're just going to do 30, that basic there. So we'll say dimension from here to here is 30 degrees. Perfect. And that's it. Good. Sketch is done. We're going to do a revolve. What are we revolving? We're revolving sketch 2. And revolve axis, well, what we want right there. So what I'll do is I'll do a select mate connector. I'm going to say that origin there. So it's revolving. We don't want to circle. We want to remove the material. We want to cut away material. Good. Check that. Perfect. Cool. Okay, what's next? We're going to need to put in the run out distance R, which really is a circle that goes to the width across flats, and then the thickness is 0.012. Okay, so we're going to sketch on this bottom here. Sketch. I bring this forward. I don't need my planes. Circle here, and I want it to snap to. And you may need to project a surface, but I think I can grab one there. There's one. That tangent point there, perfect. And then we're going to extrude that, and then the extrude is going to be 0.012. And again, that is that run out of the bearing surface, which is for 3/8 0.012. So there's just going to be a circle there on the bottom. Okay. All right. So now we're going to need the cylinder itself, and it's going to be value of E, the body diameter, and we're going to just use the maximum value of 3/8 of an inch, 0.375. Sketch on that. Bring it forward. Put a circle there on that origin, and we're going to give it 3/8 of an inch is the dimension there. Okay, good. And we're going to extrude that sketch. How far are we going to extrude this? Well, it's a 1.5 inch long screw. So depth 1.5. Perfect. All right, let's take a look here. Good. Thread time. Fun part. Okay, so we're going to need to do 2 steps. One, we're going to need to create a helix. It's a path at which the thread's going to follow. And then we also need to create the thread itself. So let's make the helix first. Here's a helix. We'll click that. And the helix is going to, we're going to set a set of turns. We're going to do pitch because we know that we need a pitch. Conical cylindrical face, we're going to follow that cylindrical face there. So you can see how it kind of puts that in there. But we want the helical pitch is 1 inch. What is the pitch? The pitch is 16 here, 16 threads per inch. threads per inch, UNC-3C inch 16. And again, how the threading table here says, the information, pitch. So it's equal to the number 1 divided by the number of threads per inch. So 1 divided by 16, 16th of an inch. So I'm going to do 1 divided by 16. Perfect. And then clockwise or counterclockwise, up to you, it doesn't matter. So we'll hit check. Good. And then we're going to end up using that curve one there at the bottom later. The helix is in there. Good. Okay, let's draw my, we're going to have to draw the thread itself. So we're going to need to do width across flats, or width across corners again. So we're going to use that front view because it goes right there at that corners. So we'll sketch on this front view there. And what we'll end up doing is creating a sweep that's going to follow that helical path, so it's a helical sweep. And so what we're going to do is draw in our triangles here to cut out the, to remove material from that cylinder. So I'm going to kind of draw out what that triangle might look like, and again, it is using this table here, and we're more specifically looking at this drawing right here. So we're going to kind of draw this shape out. So it's going to look like something like, I need something to snap to first, so construction, use and project. I want this bottom line, and I want this line there. Okay, turn that off. Okay, and so what it's going to do, it's going to look like something like this. I'm just going to kind of draw it out. And I'm going to need to draw one more for guidance. So I'm going to turn construction mode on to do this. And I'm going to draw one more line here. It's going to come up this. It's going to be a line here. It's going to come up. Perfect. Okay. I'll use that for guidance. Okay. Put some dimensions in. So we're looking at this figure right here. Let's do pitch first, P. So it's going to be the midpoints there. So I'm going to need to grab some midpoints. So we can also draw in a construction line to help guide this. So what I'll do is I'm drawing a construction line right now. I'm looking for that midpoint. There's that midpoint. I'm looking for the midpoint here. It's right there. So you can see that actually that line isn't horizontal. We're going to need to force it horizontal. It's just the way I kind of drew it. So I'm going to do the other one first. Looking for that midpoint. There it is. I'm looking for that midpoint there. So yeah, those lines need to be horizontal, but they're not. So let's force them. Horizontal constraint. There we go. And then I need to do the same thing for this guy. Perfect. Force those. Okay, let's do that pitch dimension. So from here to here is the pitch. And the pitch is 1/16, like I said before. Okay. All right. What's next? So let's do the depth. Okay, so that's the major diameter minus the minor diameter. So we're doing this major minus minor, which gives us that distance there. Divided by 2, excuse me. It's the major diameter from here to here minus the minor diameter divided by 2 because there's 2 sides. So just what we're going to do, I like to create a little formula. We're going to say from this line to here is a distance. And so the major diameter, we're going to look at the threading table here. Threading for 3/8 of an inch. The major diameter is 0.375. Minor is 0.2938. So we're going to need the order of operations. 0.375 minus 0.2938. Did I get that value right? I think so. I'll double check after this. Okay, and then that divided by 2. And was it 0.2938? Let's check. 0.2938, yep. So yeah, so that gives me that this height of the thread is 0.041, and then these are both the same because they're in line. Perfect. If they're not, you got to make sure they're both the same. All right, what's next? I know that, excuse me, I need to go. Where do I need to go? I need to go threading. Here we go. The bottom is 1/8 of an inch, 1/8 times by the pitch. That bottom, 1/8 of an inch times by the pitch. So from here to here. So let's put that distance in. So from here to here, 1 divided by 8 times by the pitch, 1 divided by 16. And using parentheses, order of operations. Good. We're going to need to do the same thing. Bring that out so you can see. Don't put in my values. Actually do the actual ones. Don't just type in 0.00. We want the exact values. We're going to do the same thing here because the top is going to be the same. So you can see how this top is 1/8 times by the pitch. So from here to here is going to need to be 1/8 times by 1/16. Perfect. Oh, I've messed up this guy. So that happens sometimes, and what you can do, I can kind of just drag this out like that. All the dimensions should stay. That way it keeps it in line. Okay. What's next? So I need some more dimensions here. I know that, what am I missing? I got that pitch there. I did the 1/8 pitch. This is 60 degrees. We can plug that in. We can also, what we'll do is also make things equal. So let's do that first. I can make this line equal to this line. That's gonna, whoa, that's gonna force the wrong way. Let's do this one first. These are gonna be messed up. Let's do the pitch first. I'm gonna need the pitch here. So from here to here is gonna also be the pitch. This is gonna be 1/16. These values are all moving things around. It's not what I want. Let's try this one first. Equal, equal. Nope. Something is not. I never set this 1 to 1. Or I'm not smart. This is going to be equal to this. There we go. And now if I did, this is equal to this. There we go. This is going to be equal to this. There we go. Perfect. We're done. There's our thread there. So I messed up because I forgot to do the dimension for this guy. I made it equal to this because that is that's 1/8 times by the pitch. So this one I forgot to do, and that's why I was throwing things off. Okay, good. All set. This sketch is done. Okay, helical sweep time. Almost done. So what we're going to do is a sweep. We're removing material. The face of the sketch is going to be sketch 5. The sweep path is going to be the curve itself. Don't hit helix when we're going to hit the curve itself. And we're going to end up merging all. And check there. And there's our thread. Okay. Pretty cool, huh? And you can also hide that curve because it's kind of like it shows up, so we can just kind of hide it. There we go, so you don't see it. So now it looks like a screw. Perfect. And go to ISO. Almost done. Let's name our part. Document name, part name itself. Copy this. Okay. Do the part itself. Name. Okay. Description. Okay. Grab that. Description 3/8 of an inch, 16 threads per inch. UNC thread, 1.5 inches long. Description here. Let's put it there as well. Keep things all equal. Part number as well. It's going to be the name of the file. It's going to be this part number there. So it's going to be 208, 163, 524, and 142. There we go. There's our part number. Good. Did I not put it in? I put it in title 1. Boy, I'm tired. Part. There we go. My fault. Good. Good. Revision 1. Apply. Okay. And then we can create our drawing. This is an Imperial A. And we're going to insert this part here. Front view. Top. A little bit redundant for these, but that's okay. There's that ISO. Perfect. We're going to show shaded view. We don't need to worry about dimensioning. That's the nice thing about these standardized bolts. I mean, we don't need to dimension. The dimensions are going to be so small to begin with, but they're standardized bolts, so we don't need to worry about dimensioning. All the information is there in the table. We forgot to set material. Don't forget that. Make sure you set your material. Assign material. Always do that before. What is the material? I skipped a step. Stainless steel, 400 series stainless steel. Okay, so we're going to type this in. Stainless steel, it's the 400 series. Perfect. So it's not going to push through. So you got to remember to do that before. Silly me. I always forget to. Drawing, shared with me. Let's bring that up again. And we're almost done. Throwing that. There's that head. Right view. ISO. And now our other information sets. Oh, my stainless steel is such a long word, it doesn't fit. We're going to need to make that smaller. 0.06, I don't know, let's try. Perfect. Something you may need to do sometimes. Just change that text so it's smaller. Should work. Perfect. And that's it. That's how we create some threads. It's a nice little thing to create threads, and so the biggest thing is kind of following your tables. Let them be your guide. Utilize the threading tables that I have on Canvas. And so if I go to the assignment, where am I? There's the fasteners, is the threading. We have reference tables here. There's also reference tables. Are going to be mechanical reference tables that would be opening up as well for different hex bolts and nuts and stuff that you can reference. Or you can also reference the entire mechanical journal that's under the resources page. Okay, but yep, that's how we're going to create the thread here for a 3/8 inch, 16 threads per inch UNC standard threading, 1.5 inch long hex cap screw.